Welcome to Delta Wings Aviation Academy, where we prepare you for takeoff.
Hello, pilots. Welcome to Delta Wing Aviation Academy, where we prepare you for takeoff. Today, we will be discussing the airfoil. We'll explore how lift is generated using both symmetric and cambered airfoils one at a time. Fasten your seatbelts as we prepare for takeoff and get a bird's eye view of the details from the sky.
What is an airfoil? The cross-sectional shape of an aircraft's wing is called an airfoil. The airfoil is primarily responsible to generate lift force, which acts perpendicular to the direction of the airflow. Lift force is created because of a pressure difference between the upper and the lower surface of the airfoil. On the upper surface of the airfoil, the flow is faster than the flow into lower surface. So the air pressure over the top surface of the airfoil is less than the air pressure under the bottom surface of the airfoil. This creates the lift force. The lift depends on the shape of the airfoil, velocity, density of air, surface area, angle of attack of the airfoil. Now let's look at some terms and definitions associated with an airfoil. Leading edge, the section of the airfoil which hits the air first. Trailing edge, the section of the airfoil which hits the air last. Chord, the distance between the leading and the trailing edge. Chord line, a straight line joining the leading and the trailing edge. Camber line, a line joining a leading and trailing edge of an airfoil and equidistant from the top and bottom surfaces. Camber, distance from the camber line to the chord line. Thickness, distance from the top surface to the bottom surface. Leading edge radius, the radius of curvature at the leading edge. If we consider an airfoil moving across a fluid, we can see a few more terms. Pitching moment, the torque or twisting force created on an airfoil by the aerodynamic forces acting on it. Center of pressure, a point on the airfoil where the resultant lift vector can be considered to be acting. Here, the pitching moment is 0. Aerodynamic center, point where the pitching moment is constant and independent of the angle of attack and lift coefficient. Angle of attack, the angle between the relative wind and the chord lag. An increase in the angle of attack results in an increase in the lift. Stall, a condition in which the lift suddenly decreases and the drag increases because of an increase in the angle of attack. Stall angle, the angle of attack at which stall occurs. Types of airfoils. This is an asymmetric airfoil. As the air hits the surface of the airfoil, the geometry causes the air to increase its velocity and decrease its pressure. In a symmetric airfoil, the top and bottom geometry are identical. Therefore, at 0 angle of attack, the pressure on top and bottom change the same, and only drag is produced. At a positive angle of attack as symmetric airfoil, the top and bottom surface have a different geometry, resulting in a pressure differential that results in a total lift vector. This lift vector can be broken down into its components of lift and drag. In a cambered airfoil, the top and bottom geometry of the airfoil are different. Therefore, even at 0 angle of attack, a pressure differential is generated, so a lift will be produced. Symmetric airfoil. The upper and lower surfaces of this airfoil are identical. The chord line and camber line are the same. Non-symmetric airfoil. The upper and lower surfaces of this airfoil are different. The chord line and camber line are different. They are also called as cambered airfoils. If the camber line is above the chord line, the lift is generated upward. If the camber line is below the chord line, the lift is generated downward. Thank you for watching. If you like the video, please subscribe.